All right, so this is lesson 6 for chapter 2, problem solving with rational numbers in fraction form. These problems are going to be a little bit more advanced, so some of you may need to stick with lesson 5 level problems, which is fine. I would much rather you work through some more basic calculations before you move to something that's really confusing you. So if I have discussed with you that you need to be sticking with lesson 5, I'm going to ask you to turn this video off and do that practice instead. Otherwise, give this a try, and if it seems too difficult or too advanced for you, let me know and we can step things back. All right, so our first example for this lesson involves order of operations with fractions. So keeping in mind order of operations and fractions, if we are going to add and subtract fractions, we need to be dealing with common denominators, and then we need to be following our order of operations, obviously. So when I look at this first example, I have 3/4 bracket, 3/5 take away 1/2, close the bracket, plus 3/10. I hope you remember that when two things are side by side like this, it actually means they're being multiplied. So this is 3/4 being multiplied to the bracket. And so when I follow my BEDMAS, I need to make sure that I answer what's inside that bracket first. Because our denominators are different and we're subtracting, we need to make them the same before we can subtract. So the easiest way, I hope you remember, is just by multiplying them by each other. And then remembering whatever you do to the bottom of the fraction, you do the same at the top. So we get 3/4 times 6/5 take away 6/10, pardon me, take away 5/10 plus 3/10. Okay, so we're going to solve what's inside the brackets first. So remembering the order of operations, I want you showing me what you're solving first. So 3/4 times 6/5, 6/10 take away 5/10, so we get left with 1/10 plus 3/10. So still keeping in mind order of operations, we have multiplying and we have addition. And so I know it's tempting to do the addition because the denominators are the same, but that's out of order. So we need to multiply next. And when we multiply fractions, we're thinking numerators times numerators, denominators times denominators. So we get 3/40 plus 3/10. Okay, in order to add our fractions, again, we need a common denominator. Yes, I know it's annoying. Yes, it takes a lot of work. And yes, you have to do it. So hopefully you notice that tenths can be made into 40ths. So I'm going to take my second equation and multiply it by 4. So 3/40 plus 12/40. We just went to all this work to make those denominators the same. So we're going to keep them the same and we get 15/40. I'm going to divide both top and bottom by 5 and we get 3/8. Neither of those numbers can be divided by a common denominator, so we get 3/8 as our final answer in lowest terms. Second example. This one looks a little crazy. We've got some division, we've got some subtraction, and we've got some more division. So following BEDMAS, we're going to do the division before we do the subtraction, and we're going to divide from left to right. So we have 2/3 divided by 4/7. So 2/3, and we're going to kiss and flip. So divide becomes multiply. 4/7 becomes 7/4. I haven't used the subtraction yet, and I'm actually going to show the second set as well of division. So 3/8 divided by, so kiss and flip, 3/8 times 5/2. Some of you might have learned cross-multiplying strategy for dividing fractions, and I'm okay with that as long as you can clearly communicate what you're doing. So again, numerators times numerators, denominators times denominators, we get 14/12, take away 15/16. I know, many of you would be tempted to just subtract, but we don't have a common denominator. So we have to think, okay, what's something that I can multiply? I could either multiply 12 by 16, but those are getting into pretty big numbers. So the other thing I could think of is common multiples. So counting by 12s and counting by 16s. And I notice that if I go 12 times 4, I get 48. And if I go 16 times 3, I get 48. So these numbers are going to be much more manageable to deal with. If we go 12 times 16, we're dealing with big numbers and it can get ugly fast. So this is what we're going to do. We're going to use a common multiple technique. And so when we do this, we get 56 over 48, take away 45 over 48. So our denominator is going to stay at 48. So we're thinking 56 take away 45, and we get 11 over 48. 11 is prime. 48 can't be divided by 11, so this is an answer in lowest terms. Again, if you are struggling with that, make sure you see me. Okay. Everybody's favorite. Two favorite things together. Fractions, well, maybe three. Fractions, order of operations, and word problems. I know. Contain your excitement. So, this problem says, at the start of the week, Timur had $30 of his monthly allowance left. Yes, Marge gives him allowance. You can understand why. That week, he spent 1/5 of the money on bus fares, another half shopping, and a quarter on snacks. How much did he have left at the end of the week? So, I want you to read through that. I want you to think of, is there any ways that I could represent this visually to help me figure it out? Literally think of what would 1/5 look like? What would half look like? What would a quarter look like? So, take a minute, try it for yourself, pause the video, and then restart. Okay, so the starting amount for all of these values is $30. And so the first amount is 1/5 on bus fares. So that means if I took this $30 and split it into 5 groups, one of those groups would be the amount that he spent on the bus. So I'm going to split it into 5. So 1, 2, 3, 4, 5 groups. They're not so even. And I need to think, okay, how much would be in each group of $30? If I'm not sure, I could go and do tick marks one by one by one until I got up to $30. Or I could think of, well, what's 30 divided by 5? That's $6. So this is 6, 6, 6, 6, 6. And those all add up to $30 if we added them up. Second amount is, so then his bus fares is 1/5. So this is his bus fare amount. That's how much he spent. The second amount says he spent half shopping. Okay, so I'm going to take my $30 and I'm going to cut it in half. So 15 and 15. So this is what he spent shopping because it was 1/2, one of the groups. Lastly is a quarter on snacks. So we're going to take the 30 and split it into 4. Well, half was 15, and so then each of these new halves we have to split 15 by 2. So that's 750, 750. And those should all add up to $30 as well. So that's for the snacks. And so that's his amount on snacks, is 1/4. So then we say, okay, well, how much does he have left? Well, I hope that you can see that he started with 30, and then he spent 6, and then he spent 15, and then he spent 750. Okay, so he ends up with $1.50 left over. Now you might have done this differently. You might have added these values up first. So you would have had $30, take away 28.50. And so you still would have got $1.50. Or you might have found a way to write an equation for this. If you can show me an equation for this, using the fractions and using the values, you might have some brackets, but if you can show me an equation for this, I will give you some bonus. That's your challenge for tomorrow. So this problem is very similar to the last one you looked at, where you're starting with the amount of money and then you are paying amounts back. This one, the wording is a little bit different. So it says Lori owed her mother $39. Lori paid back 1/3 of this debt, so 1/3 of the $39. and then later on paid back 1/4 of the remaining debt. So she paid back 1/3 of the original amount, and then whatever was still owing, she paid back 1/4 of that amount. So that's what the remaining means. So we want to know how much is she still owing. So I encourage you to try a strategy similar to what we did with $30 if you're not sure what to do. So she started with, in this case, $39, and we need to think, okay, well, we need to split that in 3. So how much is that in 3 groups? Well, $10, $20, $30. Okay, that's not split. Now we need to split up the 9. Well, 3, 6, 9. So each of those groups is $13. So that's a quick way to do it. So she paid back 1/3 of this debt. So that means $13 was paid. So now she owes her mom this $26. So this is what she has to pay back still. The second part says she then pays back 1/4 of this debt. So that means we need to take the $26 and split it into 4 groups. And I can't go by tens because there's not $40 there. I could go by fives. So 5, 10, 15, 20. So then I have $6 left that I need to split. If I go 2, 4, 6, 8, that's $2 too many. So I'm going to take off 50 cents from each. So $1.50, $3, $4.50, $6. So that means each of those groups is worth $6.50. And so we said she paid back one of these quarters. So now 3 quarters are left owing. So she owes her mom 5, 10, 15, 16, 17, 18. She owes her mom 19, 50. Again, if you can come up with one single equation using your order of operations and brackets and fractions, I will give you a bonus. Why? Because I want to. Oops, wrong way. Let's go down the page. Okay, your last example has to deal with poor Pluto. And yes, I know Pluto's not a planet anymore, but just because he's not a planet doesn't mean he's not important. So it says the diameter of Pluto is 6/17 the diameter of Mars. So 6/17 the diameter of Mars. Mars is 17/300 the diameter of Saturn. So let's just draw this out. Pluto we know is little, right? So we're going to draw a little Pluto. And the diameter of Pluto is 6/17 the diameter of Mars. I hope you caught that of was telling you to multiply there. Then we're going to draw Mars. Oh, Mars is the red planet, so I should probably use red. Okay, so this is going to be Mars. And Mars is bigger. And we said that Mars, the diameter of Mars, is 17/300 the diameter of Saturn. It is 17/300 the diameter of Saturn. So I guess Saturn's in blue. Okay? So then we want to know what fraction of the diameter of Saturn is the diameter of Pluto. This is Saturn. Okay. So we have 2 fractions that kind of in the Mars is what kind of connects them together. So we know that 6/17 times Mars. So if we went 6/17 times Mars, because this is what Mars is, right? And then if we times it by that, it will tell us Saturn, basically. That will tell us the fraction ratio. So using the 2 fractions, we're going to multiply them together to tell us what the ratio is between Pluto and Saturn. So we go 6/17 times 17 over 300 to tell us what our new ratio is going to be. I hope that some of you remember from, I think it was the last lesson, where we said if you are multiplying on the top and the bottom by the same number, it actually doesn't affect your value. So we have times by 17 on top, times by 17 on the bottom. I'm going to cancel them out to start. And now we're dealing with a fraction of 6 over 300. That is much nicer to deal with than the 102 over 5,100 we would have got. So now I know that 6 is even, and I know that 300 is even, and so both of these can be divided by 2, and I get 3 over 150. I also could have noticed that 6 and 300 are both divisible by 6. So I'm going to show that, because 3 over 150 isn't actually lowest terms. So if we go divide by 6, we get 1 over 50. 6 times 5 gives us 30, add a 0 on the end. So Pluto is 1/50th the diameter of the sun, of Saturn, pardon me. So it says the diameter of Saturn is 120,000 kilometers. What is the diameter of Pluto? And what is the diameter of Mars? So we are going to use these two ratios that we just came up with. So Pluto, we said, is 1/50th the diameter of Saturn. So 1/50th times 120,000. Okay, so in your calculator, you're going to type 1 divided by 50 times 120,000. And we get 2,400 kilometers. Oops, I left kilometers. So the diameter of Pluto is 2,400 kilometers. Okay. For Mars, we have two ways that we could do this. For Mars, we could either go backwards, so we could take the diameter of Saturn to find our solution, or we could take the diameter of Pluto to find our solution. In this case, I'm going to use the diameter of Saturn. So we know that Mars is equal to 17/300 the diameter of Saturn. Okay, and when I go 120,000 times 17 divided by 300 in my calculator, I get Mars has a diameter of 6,800 kilometers. Okay, so I know this video was a long one. These are some trickier questions, so I wanted to make sure we explain them a little bit better. You will have lots of practice time tomorrow. I encourage you to ask a lot of questions if you have them.